Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of the line which happens to be perpendicular to the vertical plane and parallel to the horizontal plane. Now since this line happens to be parallel to the horizontal plane, so its projection onto the horizontal plane, that is in the top view, we are going to obtain the true length of the line. Similarly, since this line, it happens to be perpendicular to the vertical plane, so the front view projections of this line, they will be converging with each other. So the two ends E and F, they will be converging at a point in the front view, so that the front view projections will be obtained as point view projections of this line. And this line happens to be parallel to the horizontal plane and perpendicular to the vertical plane. So this line will also be parallel to the profile plane. So therefore, we are also going to obtain the true length of the line projected onto the profile plane in the right hand side view of this particular orthographic projections. So let us read out the statement. Points E and F, so they are lying 25 millimeter above the horizontal plane. That is, both of these points E and F, so they are lying at a height or a distance of 25 millimeter above the horizontal plane, and both of these points, they lie in the first quadrant. That is, the elevation will be drawn above the XY reference line, while the plan corresponding to both of these points, it will be drawn below the XY reference line. And the distances of the points E and F from the vertical plane, they happen to be 10 millimeter and 50 millimeter respectively. That is, the top view corresponding to the point E, that is small e, it will be located 10 millimeter below the XY reference line, and the top view corresponding to the point F, that is small f, it will be located 50 millimeter below the XY reference line. And it is also provided to us that the distance between their end projectors E and F as measured parallel to the XY reference line, it is equal to 0 millimeter. That is, points E and F, they will be projected along the same vertical projector with respect to the XY reference line. That is why we are going to get EF perpendicular to the vertical plane and it will be parallel to the horizontal plane. So with this information, we are required to draw the front view projections, the top view projections, and the right hand side view projections of the line EF on the common reference lines XY and X1 Y1, and we will be joining the corresponding respective views with the object lines, that is E dash F dash we will be joining, E and F, that is the top view projections of the line also we will be joining, and we will be joining the right hand side view projections E double dash with F double dash over here. So let us proceed with the construction of the orthographic projections of this line EF, whose coordinate locations they have been provided to us. So we know that XY line we need to draw over here, and X1 Y1 line we have also drawn over here, and at the intersection point of the reference lines XY and X1 Y1, we need to draw this transfer line at an angle of 45 degree, so that whatever distances of the points will be there from the vertical plane, so those distances, they will be transferred from the top view projections onto the profile view projections in the right hand side view projections that are required to be obtained corresponding to the points E and F corresponding to the line EF. So now we know that points E and F, they are located 25 millimeter above the horizontal plane. So it means that we will be obtaining the points E dash and F dash, that is the front view projections corresponding to the points E and F as E dash and F dash onto this particular horizontal locus line at a height of 25 millimeter above the ground or above the horizontal plane. And we also know that the distance between the projectors of the ends E and F as measured parallel to the reference line, it happens to be 0 millimeter. So it means that in the front view projections, so points E dash and F dash, they are going to coincide with each other. So there is zero distance between the vertical projector line, which is going to give me the projection corresponding to the point E, and the vertical projector line, which is going to give me the projection corresponding to the point F over here. So E dash and F dash points, they will be coinciding with each other. So the moment I locate the points E dash and F dash over here, since the distance between their projectors measured parallel to the XY reference line is 0, so I know that wherever E dash projection point has been located onto this vertical projector line, which is drawn through point E dash, I will be able to locate the projection of the point E in the top view below the XY reference line. Similarly, wherever point F dash has been located, so onto this very projection line, which is a vertical projection line, I will be able to obtain the location of plan projection corresponding to the point F over here. So I know that the distances of the points E and F from the vertical plane, they happen to be 10 millimeter and 50 millimeter respectively. So I can mark a distance of 10 millimeter below the XY reference line. Why? Because the distance of the point E from the vertical plane happens to be 10 millimeter. So we will be getting the projection corresponding to the top view of the point E drawn onto the horizontal plane 10 millimeter below the XY reference line. Similarly, we also know that the projection of point F will be obtained onto the horizontal plane 50 millimeter in front of the vertical plane. So onto the same projector line from the F dash point, so we are going to move in this direction. So we will be measuring a distance of 50 millimeter from this particular XY reference line. So this is going to define 50 millimeter distance of this point F from the vertical plane. So you can check, we have marked this distance of 50 millimeter from the vertical plane corresponding to the point F over here. So now point E has been obtained in the top view projections, point F has been obtained in the top view projections. So we can join points E and F, and this construction of the line EF will provide us with the true length projection of this line EF in the top view projection. So once we obtain the true length of this line in the top view projections which have been drawn onto the horizontal plane, now we can proceed to draw the right hand side view projections corresponding to this line. And now you can check, since the right hand side view projections are to be drawn, so they will be drawn on the left hand side of the front view projections over here. So whatever distances of the points E and F, they are there from the vertical plane. So these distances of the points E and F from the vertical plane, they need to be transferred from the top view onto the profile view over here. So in order to transfer this distance of point E, what I can do? So please check, this distance happened to be 10 millimeter. So corresponding to this point E, we have drawn a horizontal construction projection line and extend it up to the transfer line which has been drawn at an angle of 45 degree. Similarly, corresponding to the point F, which is located at a distance of 50 millimeter from the vertical plane, we have drawn another horizontal construction projector line which will be extended till it meets this transfer line which was drawn at an angle of 45 degree. So onto the transfer line, 2 points have been obtained. One corresponding to the point E, which is at a distance of 10 millimeter from the vertical plane, and another point F, which is located at a distance of 50 millimeter from the vertical plane. So these two distances of 10 millimeter and 50 millimeter, so they will be transferred onto the profile plane in such a way that you need to draw a vertical projector line through the point F and bring it upwards till this vertical projector line intersects with the horizontal projection line which is emerging from the point F dash in the front view. So wherever these two projector lines, that is horizontal projector line emerging from point F dash in the front view and the vertical projector line corresponding to point F of the top view. So wherever these two projectors they join, we obtain the location of the point F in the right hand side view projections onto the profile plane. So point F double dash has been obtained over here. Similarly, in order to obtain point E double dash, so once again same procedure will be followed. We have drawn a horizontal locus line through the front view projection point E dash and extended into the profile view projection, and from the top view this distance was 10 millimeter. So this point E has been shifted onto the transfer line, and now from the transfer line again a vertical projector will be drawn and extended till this vertical projector drawn through the point E corresponding to the planned distance from the vertical plane. So this distance of 10 millimeter, this is 10 millimeter once again. We have transferred this distance from the top view into the side view. Now this vertical projector will be extended in the profile view till this vertical projector extends and it intersects with the horizontal construction line which has been drawn through the point E dash in the front view projection. So point E double dash will be located over here. So having located and identified points E double dash and F double dash in the right hand side view projections, so we can join E double dash with F double dash, and we will find that this distance E double dash and F double dash, it also happens to be the true length. Why? Because this line happened to be parallel to the horizontal plane and perpendicular to the vertical plane. So this will be virtually parallel to the profile plane. So because this line EF happens to be parallel to the profile plane, so onto the profile plane once again, that is in the right hand side view projections, we have been able to obtain true length projections of this line as E double dash F double dash. So this way we have been able to obtain the true length projections of this line onto the horizontal plane, point view projections of this line onto the vertical plane, and true length projections of this line onto the right hand side view projections onto the profile plane. So this way we have been able to evaluate the orthographic projections of a line which happens to be perpendicular to the vertical plane and parallel to the horizontal plane. So this is all for today. So I hope that through this discussion you would have understood about the mechanism to develop the orthographic projections of a line perpendicular to the vertical plane and parallel to the horizontal plane. So we'll be continuing with further discussion regarding few more illustrative cases regarding the projections of the line in the coming lectures. So thank you very much. Thanks a lot.